Okay, in this video, we're going to look at this question. It says, copy and complete Table 1 in evidence and complete the analysis of the following investigation report. The purpose of this investigation is to use titration to standardize a solution of hydrochloric acid. What is the amount concentration of hydrochloric acid solution? So a standard sodium carbonate solution is prepared. Samples of the standard solution are titrated with an unknown sample of hydrochloric acid. The color change of methyl orange is used to indicate the end point. So they've got titration of 10 milliliters at 0.12 mole of sodium carbonate with hydrochloric acid. So I've written out the reaction here, and I've organized the concentration of sodium carbonate, because it was given to me, as well as the volume. We want to find the concentration of hydrochloric acid, but we do not yet know its volume. So we need to look here, and we're going to subtract the numbers here. So if I take 17.9 minus 0.3, I get 17.6 milliliters. And then 35 minus 17.9 is 17.1 milliliters. This is going to be 17.0 milliliters because I'm subtracting these numbers. And this one is going to be, so 40.1 minus 22.9 is 17.2 milliliters. So these three samples are within plus or minus 0.1 milliliters of each other. So I'm going to use those to get my average volume. So my volume of hydrochloric acid is going to be 17.1 milliliters plus 17.0 milliliters plus 17.2 milliliters. And I'm going to divide those all by 3, and my average volume is 17.1 milliliters. So now I'm going to be able to do my calculation. I'm going to want to get the concentration of hydrochloric acid. I'm going to start with 10.00 milliliters of sodium carbonate. I want to get rid of the liters and be left with mole. This will actually give me millimole per liter. And so this gives me the chemical amount of sodium carbonate, and it'll be in millimole per liter, but that's okay because I'm going to get rid of that later. I get 2 hydrochloric acids, and for every 1 sodium carbonate. And so this gives me the number of moles or millimoles of hydrochloric acid. But if I divide by the volume, I'm going to get the concentration is N over V. So by dividing by the volume, I get a concentration. But I'm going to divide by milliliters, because 17.1 milliliters, I get my liters canceling out, gets me my millimoles, but then my millis cancel out, and I get mole per liter. So I'm going to take 10 times 0.12 times 2 divided by 1, and then divided by 17.1. And my answer is 0.140 mole per liter, and that gives me my concentration. So every time I'm doing a titration, I'm going to need to find that average volume using the 3 trials that are within plus or minus 0.1 for a net change of 0.2. And I'm going to be multiplying a concentration times a volume, finding the number of moles using the coefficients, and then dividing by the volume of the unknown.